So I wanted to do a different type of presentation about quality engineering. We usually talk about quality engineering for testers, but I want to maybe look at it from a point of view of an IT leader or a project manager, because they are actually interested in quality engineering. This is a conversation we're having more and more in Tesena, that we've been approached by various organizations which have been, let's say, struggling for a while with agilization, with digitalization, that feel that they've got stuck somewhere, that the promises of going agile have not been realized. They've got some frustrations. They feel it's not working very well. And they actually come to us and say, we've heard you talk about quality engineering. What can you tell us about it? How could it help us? So what I want to do today is try and go through some of the ways that quality engineering can help, will help, and to take it from the point of view of a top-down vision about software delivery overall. So that's the start. Hopefully I remembered everything I'm supposed to say at the start, and I'll get started with the slides. So first of all, we have the software delivery lifecycle, and that starts with some requirements, some design, planning, coding, testing, deployment, and maintenance. And you'll see this pattern in almost every team. Every team we talk to about quality engineering, we get them to sit down and describe what their delivery process looks like, and it generally looks pretty much similar to this. You might have planning before design or something like that, but generally it's the same. And it looks like waterfall, this sort of like these phases, but even when you talk to agile teams or even Kanban teams, they've still basically got the same steps in the process. If you look at a Kanban board, if it's a Scrum team or a Kanban team, you'll definitely see the similar steps. So this sort of process of steps as we go down the line really reminds you, like, but this is waterfall. No, why are we still doing it in the same way in agile? Why is it didn't change? The only thing that I see difference between a waterfall project and a Scrum team is that they do this project every 2 weeks. It's basically they just keep doing the little projects over and over again, like what we used to do in waterfall. And waterfall was pretty painful, so sometimes imagine that for an agile team to go through the same cycle of sometimes pain over and over again must be pretty frustrating. So why does it always feel like this? Well, it's because it actually works, sort of. And waterfall, this approach we have to dealing with things in a production line way, it's like a habit and it's hard to break. And the reason for that, according to me, is because of maybe these two guys. So jumping back in time, we have two guys. One was Frederick Winslow Taylor, and you might have heard of something called Taylorism, and maybe you know where it comes from, and maybe you don't, but basically it comes from this guy, and it comes from this book he wrote, The Principles of Scientific Management. And in the day, it was as popular, this book was as popular as a Taylor Swift album today. And Mr. Taylor really liked things to be very well organized, and he was frustrated with things that worked inefficiently. And for some reason, he was an educated guy, but he decided to go and work in some steelworks as a supervisor. And he was really, really sort of upset with the craftsmen who worked there, because first thing, they wouldn't tell anybody else how to do things. They were the craftsmen, and they were the guys that knew how to do things. And it just looked to Mr. Taylor like everything was being done in a very, very inefficient way. And he said, this is one of his quotes, is hardly a competent workman can be found who does not devote a considerable amount of time to studying just how slowly he can work and still convince employer that he's going at a good pace. So you can imagine his opinion on workmen. And this book of scientific management was really very popular in the day. And at the same time, but not influenced directly by Mr. Taylor, Henry Ford had a vision. He had a vision to change the world. And it's really quite a serious thing, because he said he wanted to build a car that was affordable for any working man with a reasonable wage. And in 1913, that was a big statement, because only very, very rich people could afford an automobile. So Henry Ford designed a very cheap car, the Model T Ford, but still it wasn't enough. He needed to find a way to make that car as cheaply as possible. So he had to focus on productivity. So Henry Ford invented, well, he didn't really invent, he introduced the first let's say, fully automated moving production line. Production lines existed before, but this was the first one where it was a moving production line from beginning to end. And this invention, or this combination of ideas, in fact, made it possible to reduce the time to manufacture a car from 12 hours, which was already pretty quick, to 90 minutes. And he was able to reduce the price with his productivity. He was able to reduce the price of the car from, I think if I remember correctly, about $900 when he started making them to $380 when he finished. So that he managed to increase productivity over time, and over the 10 or 12 years while they were making the Model T Ford, he was able to reduce the cost of the car, and he built, I think, 10 million cars, and it changed the world. Everybody suddenly was able to buy a car. This was a world-changing event. So it was quite a significant thing, and people came to Henry Ford's factory and saw this amazing thing, this moving production line. They saw the productivity, they saw what it could achieve. Everything we have today is affordable only because of mass production. Your telephone, your computer, your glasses on your face, your clothes. It's only because of mass production that we can actually afford these things. So this was a breakthrough change in humanity. So because of that, they saw this miracle. They also saw how much money Henry Ford was making, and everybody said, wow, this is a great idea. Let's go away and implement this same idea everywhere else. So mass production took off in the world. And it was applied in manufacturing, and eventually it got applied even to white collar working. I think in the 50s and 60s, you had the company man, and everything was process based. Everything was organized like in a production line. And also in IT, it came. When I started in IT in the 80s, a long time ago, but I started in IT in the 80s, it was very, very process organized, yeah, and very rigid. We had to fill out a form, we had to use certain templates, there was a given process, there were certain steps we had to do. So this idea of this Tayloristic or Henry Ford approach was even good in software development. And well, in fact, the idea of waterfall was first quoted as not because it was a good way of doing software development. It was actually described as a bad way of doing software development. Yeah, it was actually explained as an anti-pattern, saying this is not a good way to do software development. But still, we did it. It was inbuilt. It's an ingrained habit. Now, the idea behind all this waterfallness is productivity, and what the basic steps of the process are is to decompose a complicated activity into simple standardized tasks. So you have the craftsman working in the steelworks or in the automotive industry, and you took what he did and just broke it down to very simple tasks, which means that anybody basically could do those tasks, and you reduce your reliance on skilled, therefore, which are scarce and expensive workers. So you can reduce your manufacturing costs by using cheaper labor. Then you apply time and motion. You increase the flow of the work and reduce effort. Everything was minimized, that movements of the workers were minimized as much as possible. If you had to screw something on there, the bolt was over here. In fact, Henry Ford invented the moving production line to stop the worker having to move at all. The worker stood in one place all day. And if he's standing in one place the whole day, it means he's doing the same task over and over again. So workers perform one specific task, and then you monitor everything. You can see how fast the workers are working, how fast the production line is moving. And if you're meeting the quotas, everybody gets a reward. And if you don't meet the quotas, then you get punished. And this change, as I said, this process changed the world and made people a lot of money. So it becomes, from my point of view, a cognitive bias. It was, if you look at project management methodologies and you look at Google about people writing about Taylorism, these project managers saying Taylor was a genius. Yeah, he was a great guy, he was a genius. So it became like a cognitive bias because it was so successful. Humans, when they see something work, yeah, they tend to switch to automatic mode. Okay, that worked, so I'll just keep repeating that. They don't change things when they feel like it works. It's how our brains just can't do so many things, so we work on automatic most of the time, you probably know. But there's a downside of all this. The first one is the division of labor. Everybody does a specific task, which means people are specialized, which in IT means we've got business analysts, developers, and testers, and they work in silos. Yeah, because the business has to do their business requirements and do their business design. You might have an IT analyst who works on some technical design. Then you have a developer who develops something. Then you have a tester who tests something, and so on and so forth. So you have these silos. And if you have silos, you have the handoffs. Yeah, here's my business requirements. You hand them over to somebody else who then does something else with those and then hands over the results of that work to somebody else. So we have these hands up. For me, also there you have the idea of these best practices. I don't like the idea of a best practice. I like good practices, yeah, and I like to combine good practices to try and find a good practice that works in my environment. But there's never one best way of doing anything. That's just not possible. There's always a better way of doing something. And then you have rigid processes. And because you have rigid processes and best practices, there's a risk to change. And you hear this a lot. This is the way we always did this. So why do we need to change? Yeah, as an external consultant, I tend to go to place and say, "Why are you doing it like that?" Doing it like that, and the answer, "Because we always did it like this. Why do we need to change?" And the final thing is the idea of not stopping the line. In Henry Ford's day, you could never ever stop the production line. The production line had to keep going. That's how the main productivity. You had to feed work into the production line, and you had to keep the workers busy the whole time. You never stopped the line, no matter what happened. You didn't stop the line. And where is the role of testing in this production line? Well, testing typically, even today, is at the end, and it has a good reason. We do testing at the end to try and prevent any defects getting in production. And when we do that, we save money, we can help save the reputation of the organization, and we can help save a lot of people maybe sleepless nights that they've got some serious problem in production and they have to resolve it. So testing is a good thing, and that's why we typically do it at the end. And there's another reasons why we do testing typically at the end. One, I think, is confidence. Yeah. So often when I'm talking about things like the test pyramid, people say, "Oh no, we have to test it when it's all finished, when it's all built." We're not really sure it's going to work if we just test the little parts, and then when we put it all together, it doesn't guarantee it's going to work. So people like to see things working on the finished product when it's finished. So we do testing at the end. Speed, yeah, because we've got this not stop the line idea, yeah, then if we get testers involved earlier, then we're slowing things down, aren't we? Because testers have to test things and the developer has to wait, or somebody has to wait for something else. We're waiting for QA to do something. We don't want to wait. We want to keep going. We'll do testing at the end. It's more efficient. It looks better that we just do testing once rather than several times. If you do it several times, it's not inefficient, no? We'll just do it at the end. So these are some of the reasons why we do testing typically just at the end. So let's talk about defects and maybe incidents. Where do they come from? You know, it's like babies. Where do they come from? Let's think about where incidents and defects come from. So basically we start with an error. That's a human mistake. And that's an action, something that happens. And that may cause a fault, which is a manifestation of the error. So for example, you'll see something in the code that's wrong. So the developers receive that. You might see something in the specification that's wrong. That's the manifestation that somebody's made an error. This can lead to a failure in the system, which we often call a defect. Yeah, the system fails to perform as expected. Yeah, and that's what the users would see. And if you don't catch that defect in time, then that failure, could get into production where it becomes an incident. So that's where defects and incidents come from, and defects are always going to happen because software is still built by humans. Even in this day of AI and all the things that AI promises, I'm still thinking humans will be in the process somewhere for a long time to come. Whether a long time is 10 years or 50 years, I don't know, but it seems to me AI is not going to take over software development completely in maybe the near future. And to make mistakes is a very human trait. We do it the whole time, even if we realize it or not. We're making mistakes the whole time. We are far from perfect beings, and therefore we make mistakes. So it's fairly normal, and I would say to some extent acceptable, that mistakes do happen. So therefore we'll always have some level of defects. And where do these mistakes happen in this software development life cycle? Well, too long to don't read. They can happen anywhere, at any point. You can have problems with the business requirements. You can have problem in the code. You can have problem in the test code. You can have problems in the test cases, whatever. Mistakes can happen everywhere because all those things are being done by humans with the help of AI these days. So what happens when we find a defect? Well, the first example is that in testing, which is at the end, we find a defect and we hear from the developer that it works on their machine. I don't know if this happens so much these days, but this used to be a thing when I was younger. And it was kind of like a sad joke. You used to hear it repeatedly. Well, I tried to replicate this defect and I can't get it to work. I can't get that defect to happen on my machine. And I usually related this down. My root cause analysis was that you didn't package that piece of software probably didn't get into the build. That change didn't get into the build, sorry, or it maybe didn't get delivered with the build, or it wasn't deployed properly, or wasn't configured properly. Yeah, so maybe it works on your local machine where you've got everything nicely built and everything's correct, but on our environment, it doesn't work. Then the next one, and the impact of that is that you have to do the repackaging, you have to redeploy it, and then you have to retest it. So there's some that we have to do there. The next example is somebody makes a mistake while coding. Yeah, it's a bug. What happens in that case? Well, we have to fix the code, we have to repackage the code, we have to redeploy the code, and then we have to retest the code. So more re's. And then it could be a problem in the design. And often these are called change requests on project, but they're not. They're design bugs. Yeah, and I really used to irritate me as a test manager that we used to have change requests, but it was a bug in the design. Yeah, it's not a change request. Yeah, so what happens in this case? Well, we have to redesign, recode, repackage, redeploy, retest. I'm getting your point. You're getting the point now, aren't you? Yeah, and if it's in the requirements, then we usually hear that business don't know what they want. Yeah, but it's not. Maybe we didn't understand what they need. Yeah, so in that case, we just get frustrated business people and we start the whole process from the beginning. You get the idea. Defects cause rework. Yeah, when we find the defect, we have to go back and redo something. And how much rework you do depends on where the error was made. Yeah, so if it's in the requirements, then we've got a lot of rework to do. So my question is, which way is the water flowing? The joke about waterfall when it was originally described was it only goes one way. There's no way to go back. But that's silly because it seems to me we're swimming against the flow the whole time in waterfall or in agile or in scrum or whatever. It seems we're going round and round and round like a salmon going down the stream and then coming back up the stream to die at the end. So let's talk about flow. Flow is a very interesting concept in quality engineering. Now, where does flow come from? Well, Henry Ford invented manufacturing lines and Toyota invented flow. So we're back in the automotive. And in post-World War II Japan, the economy was destroyed. They had nothing. They had no raw materials. They had very little electricity and energy and so forth. They had very few skilled workers, unfortunately. Yeah, and they wanted to rebuild the economy. And the guys from Toyota went to visit Henry Ford's factories and they said, yes, very nice, but we can't do it like that. We can't waste things. We don't have the raw materials to waste things. We can't afford to make mistakes. We can't afford the rework. If we make a mistake, it means we have to scrap something. We don't have the materials to afford to scrap something. So they're very, very focused on trying to reduce the waste and the defects in the process. Yeah, and this enabled Toyota to go from literally nowhere in 1950 as one of the manufacturers of passenger vehicles to being the biggest automobile manufacturer in, I think it was around year 2000. They finally overtook General Motors. General Motors until that point was the biggest. And the Toyota production system, these ideas which are in the Toyota production system, which of course developed over a number of years, led to a number of things you might have heard of. One of them is lean. It also influenced heavily Agile. It also influences heavily DevOps. And I think also because QE for me is an extension of DevOps, but let's say a way of taking these ideas which have been proven in DevOps environment and applying them into any software development lifecycle. So it's also part of the foundation stones of quality engineering. And when we look at quality engineering, we tend to look at things in lean and things in DevOps as inspiration. So their idea was to maximize the flow of the production, taking the idea, and getting it to the customer. Maximize the customer value by maximizing the flow. And as I said, to reduce waste. They couldn't afford any waste in the production process. So they're really, really focused on not making mistakes or catching mistakes early. So here, for example, I've got a production line, which is, let's say, a team. They've had a need. They've probably got a couple of business analysts who work in some design. I see there's a fault in my presentation. And then they imagine 3 coding boxes. And in one of the coding boxes, one of the developers makes a mistake. This leads to a fault. That fault then gets into the build. We find it in the test. And if we don't catch it in the test, we've released. Okay, so it impacts the whole process. It has impacts the downstream. It causes extra work. We have to go back and fix it. And if we're in an automotive environment, if we catch it at the end, because also the auto manufacturers tend to have the quality control right at the end. If they catch it at the end, then basically the car has to go to the car park outside the factory, and it's called the repass car park. And then somebody has to go out there and try and fix it. So they have to fix in the car park, which is quite expensive, yeah, especially when the car's already built and they find out there's something basically wrong with the car. They have to take the car apart, fix the thing, and then put the car back together again. Just a bit like redoing software, but software's a bit easier to do that with than a car. And if it gets out into production, then obviously the client has a problem and they have to fix it at the client. The client has to go to the service and get the car fixed in part of the warranty. And if that mistake happens sooner, like for design, then we have a fault in the design, which then causes maybe the developers to make mistakes because there's something not clear in the design, something incorrect in the design, so they can make more mistakes. So that impacts the downstream. You get more mistakes, it builds into a bigger problem. That gets into the build, into the test, into the release. And in an automotive environment, you might have to just throw the car away. Those mistakes have added to each other as you've gone down the line, and eventually the car's, I can't fix this. We just have to scrap the whole thing, which is pretty expensive. And then if you get the release, you might have to do a general recall, which is for automotive the worst thing that can happen. If they have to recall hundreds of thousands of cars to fix a problem, which was a problem in the design, and this can happen. So this is the reason why they have to be very careful about getting mistakes. So the faults can cause other people to make mistakes, causing additional faults, leading to bigger failures. So this is why Toyota said, don't let the mistakes go down the line. They say, stop the line. They're teams of people, and they have teams of people working on the production line. And if they see any sort of mistake, if they make sort of mistake, if they can't finish the task they're supposed to do, they stop the line. They have a code. They're the famous and-done code. They pull the line. There's a few minutes before the line actually stops. While they try and figure out the problem, the boss comes over, the rest of the team come over. They try and figure it out in the few minutes that they have, and if they still can't solve it, they stop the line. The production line in Toyota is stopped while they solve that problem, no matter how big or small the problem is. So they fix the problem, they identify the problem immediately, or they try to identify the problem immediately, and they try and fix it immediately. They don't let it go down the line. So why do people make mistakes? Well, the first one I think we see quite often is you're just overloaded. Yeah, the more overloaded you are, the more mistakes you make. Yeah, you get tired, you've got too many things to do, you're context switching too much, you just make more mistakes. I know this, I'm context switching the whole time, and I make hundreds of mistakes every day. Misunderstandings. I think this is the biggest thing in humankind. We're not very good at communicating with each other, and misunderstandings are happening all the time. And every time you get a handoff on this production line, then there's a chance that you'll misunderstand each other. Somebody prepares the business requirements, somebody takes that and starts preparing a detailed specification, there's a chance there's a misunderstanding. So every time we have a handoff, we increase the chances of misunderstandings. I don't know what I'm doing. Yeah, I've got a job, I've got a task, and I don't know how to do it. I don't know what I'm doing. This can happen. We tend to not to admit that we don't know what we're doing, so we carry on and just do the best we can. Poor processes and standards. I think this happens quite a lot, that the process is not very good, or we haven't got any standards we should be trying to do this to. Yeah, how many times we talk to teams and say, have you got coding standards? And they say, well, you know, we've got at least some scanning going off, but we don't really have standards. Okay. Poor tools. Yeah, this can happen these days. If we're using AI and we're not using it very well, then we can consider that a poor tool. We might be missing a quality culture. people in the team might not be feeling responsible for the quality of their work. If you've got handoffs and you're passing things down the line and the quality is done by the tester, the quality check is done by the tester at the end, then maybe the developer's thinking like, it's his job to check the quality. I'm not going to check the quality of my work. I've certainly seen this situation. And the last one maybe is sabotage. It rarely happens. I guess it does happen, but people don't tend to sabotage things on purpose. There has to be some maybe other issue going on that causes somebody to start sabotaging work. And when we have a person who's making mistakes, maybe because they're overloaded or they don't really know what they're doing or they're not using the right tools or they're not following a standard, then every time we send a defect back, we find a defect and we send the work back, they become more overloaded. And what happens? They can make more mistakes. So basically just compounding the problem. You're making the overloaded person even more overloaded because the results of his mistakes are just coming back and he has to try and solve them. And we know in IT that every time we try and fix a problem, then we can break something else. This is probably a key factor in software testing, that we're always thinking about regression testing. Even more so in Agile these days, regression testing really became a big thing with Agile, because repeating the cycle over and over again, you need to do regression testing. Every time you change something, you can break something. And I remember as a developer being called at 3 o'clock in the morning because during the day I'd made a minor change to a screen somewhere and we put it live, and I went home and said, great. And 3 o'clock in the morning, they said, Phil, the batch has failed. What did you do today? Oh, and I had to go in at 4 o'clock in the morning, and the operations team is standing, looking over my shoulder, waiting me to fix the problem and try and get the batch running again. Yeah, I've been through that. It wasn't nice. I'm really focused on regression testing as a software tester. And when we go back to Toyota, they have 7 types of waste. First one are defects. We've talked about that enough. The second one is overproduction. Yeah, this is waste because you've created something that nobody wants. Yeah, why did you produce it if nobody wants it? This can happen a lot in IT. We think it's a good idea and we develop it, roll it out, but nobody actually uses it. So that's overproduction. Waiting. And that's waste too. If you're waiting for something, then you're not doing anything for a certain amount of time while you're waiting. So if you're waiting for some approval or someone to make a decision, or you're waiting for the person before you to actually finish something before you can start, it's waste. Transport. We talked about handoffs. Every time you hand off something, it's taking time. Somebody has to take a task from somebody else, try and figure out what they need to do on that task and start working on it. Extra processing. You're doing stuff that you don't need to do. I think in Agile Manifesto, we have the working software over comprehensive documentation. The idea is there that comprehensive documentation maybe is extra processing. Good enough documentation is what you need to aim for. Inventory. You've got in your backlog lots of features. Yeah, you've maybe started developing some features, but you couldn't finish them. You didn't finish the work. You didn't get it out the door. You didn't deliver to the customer. This is inventory. This is stuff lying around that's not finished and is clogging up the pipeline. You might have code you've developed that's not used, designs, untested features. And motion. And in IT context, motion is task switching. It's very expensive. I'm sure you all know. If you're working on something and then somebody comes and says, Phil, could you look at this? And you start looking at that, and then you finish looking at that, and then you come back to this and you have to start again, sort of thing. What was I doing? What was that thought I had before I switched to the other two? So that's very expensive. Context switching is very expensive. So imagine in software development, a developer develops something, sends it to the tester. The tester doesn't manage to do it for a couple of weeks, but manages to test it like in the 3rd week and then finds a defect. He sends it back to the developer and the developer goes, what did I do 3 weeks ago? What was this feature about? You have to get back into it, analyze again. So this task switching is very, very expensive. So if we go back to this diagram and we've got our rework, well, we can add in there the motion. Because every time we go back, there's a certain amount of task switching. We've got the transport. We have to go through those handoffs over and over again. And if you're actually developing features based on poor requirements, you develop something that nobody wants. That's overproduction. Why did you do it? Stop and make sure you've got the requirements right before you even start. And if your process is already wasteful because it's full of waiting, transport, extra processing and inventory, and many processes are, then defects will just clog up the system even more. So this flow is very, very important in quality engineering. We try and make sure, we try and find places where this process is not working very well, where it's wasteful to try and make the flow, maximize the flow of value from the idea to the customer. So basically, why do we work like this? We do it every day. And I think many of us don't even stop to ask, why? Why isn't there a better way? And this is why IT leaders are now saying, okay, we've switched from waterfall to agile, but it looks the same, it feels the same, maybe feels even worse in some cases. We've had enough. We want to find a different way to do it. Can this quality engineering help us? And I believe it can. There is hope. It's quality engineering. Or at least I hope there is hope. It's quality engineering. Let me just try and explain some basic principles about quality engineering. Maybe you've heard about it, maybe you don't know what it is. And when a year ago, a year and a half ago, I asked our marketing ladies, I was saying, I need a graphic that explains in one graphic what quality engineering is. And she sent me this. And I went, okay, this is great. This is perfect. So let me go through the elements. Yeah? Shift left. Yeah? It's the idea of continuously building in quality. Yeah? Don't wait to the end to find out it's not good quality, then go back, but try and build it in as you go. This is the idea behind shift left. I actually prefer shift everywhere because, shift left, many people say, oh, shift left means we go one step. Yeah, we do maybe more testing in development. No, we shift quality control and trying to improve quality to the whole process. Shift it everywhere. We have quality measures. This is taken from TMAP, quality for cross-functional teams. They talk about 3 types of quality measures. And quality measures, because they're Dutch, from Holland, they use English in a very specific way. And a quality measure is a measurement? No, it's an activity. And there's 3 types of quality measures. One is to prevent quality issues, so we try and prevent them actually happening. We detect that quality or the value that we're looking for is built in. That's mostly done by testing. And then when we find quality issues, then there's activities to correct them. Then we have the idea behind continuous improvement. We want to continuously improve the product, of course, but the product is the result of a process and the work of the people who are working in the process. So quality engineering just doesn't focus on improving the product. It looks at improving the process. I've talked about flow. This is what I'm talking about. We actually look at the process and try and find if we can improve it. And by improving the process, we can improve the product, the quality of the product. We also look at the quality of the people. We can look at how we can improve the know-how and the knowledge of the people to help improve the product. Then we have continuous learning. If we want to do continuous improvement, then first we have to learn what we're not doing well. And this is actually quite a difficult thing. I have quite a few presentations on continuous learning, but basically it means you have to recognize you've made a mistake or recognize that it could be done in a better way and try and figure out what's causing that thing to happen and then think about how you can improve it. That's continuous learning. And it's pretty hard to do that because the human ego doesn't like to admit that we're imperfect and that we make mistakes. So actually opening yourself individually and as a team to looking at whether you've made mistakes, it's actually pretty difficult. It can be quite challenging. And for us, the thing around the whole thing is teaming. As we talk to teams, we've realized that the magic in quality engineering comes from the team and how the team works. And nothing can work. Continuous learning, continuous improvement, shift left, nothing can work without the team actually starting to work in a different way or working in these ways which we talk about. And finally, the loop. Why we call it a loop? Because it just keeps going round and round. This is the Deming cycle. It's continuous improvement. Now, quality engineering has 3 main aspects. I've already mentioned this. We look at the quality of the product, we look at the process, the quality of the process that builds the product, and we look at the quality of people that are involved in the process building the product. But we can't forget about tools. We need to use the right tools. These days, we don't do software development without tools. AI is just another tool in our toolbox. We also need to think about supply chains. This is one of the key things in Toyota. They didn't just solve their part of the production process. They think about the whole supply chain. They actually go back to their suppliers and agree on how it's going to work. So when you're in an agile environment where you maybe have multiple tribes, we often see that the tribes are working very much in isolation. And they're complaining about each other. Oh, those guys don't deliver us the things we want on time, or they always get it wrong, or they're always late, or they don't understand us, whatever. Yeah, Toyota actually tried to make sure that everybody understood the dependencies in the whole chain, and found out ways to work overall to make it all work. So these relationships between different teams are very, very important. Now, the theory of constraints is a thing that gets repeated often in Lean. I just want to quickly explain what it is. And we're also looking for this in quality engineering. In any process, there's usually one part that limits the speed of the whole process. Yeah. So imagine you have two product owners, but only one business analyst and 10 programmers. Where's the narrow part of that? Where's the constraint in that process? It's going to be the business analyst. The business analyst is not going to manage. He's going to slow down the whole process. All the developers downstream are going to be waiting for the business analyst. Yeah, and it might not be that you don't have enough capacity there, that you might have enough business analysts, but it could just be making mistakes for the reasons I've already mentioned. Yeah, which leads to waste, which slows down the process. So a defect is we find out it doesn't work as expected. The fault could be, I'm giving an example, we have incomplete and unreliable business requirements and acceptance criteria. We've traced the fault back to where it is. And what's the constraint? Well, the business analyst is struggling with the definition of the business requirements and the acceptance criteria. So that's where we have the constraint. And in quality engineering, we need to look at that. We need to say, okay, we've got something here. The quality, when we get to the end, is not very good. Well, where does that start? Where's the constraint? What's causing this problem to start? And what can we do about it? So the first step is to identify a constraint. That's the learning part. And then you have to decide what to do with it, the improvement part. So how do we identify the constraint? Well, we have a process, yeah, and it's based on the Lean principle, or I think it's in DevOps too, that you have to make the work visible. You have to make all the pipeline visible. So you sit the whole team down together, and the team together describes how they work. And you'd be surprised by finding out that most of the team doesn't see what the rest of the team does. And they're sitting there, oh, I didn't know we do that. Oh, we've got that. I didn't know this. Even the product owner will be learning from the developers what they do, and the testers will be learning from the business analysts what they do, and vice versa. And the team sits down and identifies the weaknesses in that process. And then the team starts to work on defining improvements. In our experience, the team knows where the problems are. They just don't talk about them. They don't feel that the environment they're in is safe for them to actually talk about these things, to bring them out and to start discussing them. Or nobody wants to discuss them because it feels like critical. If I come to the business analyst and say, well, your business analyst is not very good, I can't know what to do with it. Oh, I'm being criticized. Yeah, so it's very, very sensitive for people to work like where these things aren't working very well. They know what the problem is, they don't talk about it. So, and we also found out that teams actually know how to solve the problems pretty much on their own. When they identify the problem, we say, okay, what can you do about it? They come up with a lot of ideas about how to solve it. So they know how to solve it. It's just need to get them there so they're able to identify where the constraints are. We do that through a quality engineering workshop. This is what we do for our clients quite frequently. We take the whole team somewhere together for a day. We facilitate the workshop. We set up a safe environment for them. We take them through the process of describing the whole flow, take them through the process of trying to map the points where they have problems, and then get the team to work on providing some solutions. It's a very, very effective approach. It takes some energy. It takes some bravery from the team because they have to start facing the fact that they need to change. But generally, we have a very good experience with this approach. It might take a while for it to get hold, but like we can show the team that there's a better way. Now, we talked about the quality measures. Detective is quality there. Preventative is to build quality in the first time, and corrective is to proactively improve quality. Now, detective is testing. Yeah. So we know a lot of different ways to do testing. It could be static testing, review of documents, whatever. Yeah, it could be some code analysis. It could be dynamic testing, which we all know and love. It could be monitoring. It could be alerting, running analysis on logs, canary releases. I actually had a longer list. I just took some that I recognize myself. So there's lots of testing type activities. Detective activities, we can say, is the quality there. Now, the idea, if we take it from Toyota, is if you see a workstation that's making lots of mistakes, that's your constraint. Then you put the quality control immediately after that workstation. Therefore, you can send the work back immediately when you can see it's wrong. So you don't have to let that thing go down the line where it causes other people to make mistakes, and you get a bigger and bigger number of faults, and you come to the point at the end you just have to throw the whole thing away. So if you realize that one of the analysts is not doing, he's struggling, then you put a quality control step right after that. That's shift left testing. You have to identify where the problem is and move the quality assurance after that point. If it's in coding, you could say, okay, we need here unit testing. If it's in integration, we need better integration testing. If we have problems with the integration design, we say, okay, we need contract-driven testing. If it's problems with the quality of the code, let's do test-driven development, for example. So you can do a lot of things. You put there the quality control step immediately afterwards. You don't wait for the end. You catch it early. And therefore you avoid overloading the station, you avoid all that but you have to be brave enough to stop the line. You have to say, okay, it's not good. We have to fix it before we go any further. And in most environments, the team is under pressure because we have a not stop the line culture, let's say, from the management that the team also has to be producing. So therefore, if they see something's wrong, they don't stop. This would be a big thing on waterfall projects. Yeah, I used to be the test manager, and they used to say, yeah, the specifications have all been signed off. And I was saying, but they're terrible. No, but we've signed them off. We've hit the deadline. Let's start with the development. I was saying, but the specifications are terrible. No, we have to keep going. And I think it's the same these days in waterfall environments, in agile environments. The preventative measures, try to build the quality in the first time. We find definition of ready and definition done are really good at this. Yeah, stop. Are you ready to continue? Are you done? Have you really done this task? Yeah. If it's not done, then don't continue. Prevent things by involving testing early. Testers are very good at spotting things very early and asking good questions. Yeah, it's not like we're spotting errors, but we can actually contribute to the quality of the thing, to build in the quality. Acceptance criteria is a good thing. Like, make sure we understand the thing before we go further. Coding standards, using good tools, cross-functional collaboration, test-driven development, behavior development. You actually build it. You actually define the test before you do the coding. And in corrective, the big thing for me is make sure you have time to really do retrospective lessons learned and collect feedback, yeah, and learn from it. And have time, bosses, we have time in the next sprint to actually make some changes. Teams often say, okay, we have the retrospective, we've decided what's wrong and what we want to improve, but nobody ever gives us time to actually work on solving it. We need time in the sprint to actually solve those problems. Other corrective measures you can have, okay, so you can fix a defect, that's an obvious one, but bad code or poor architecture can cause a lot of defects. So you have to improve or refactor fragile, complex code, make it simpler to maintain, improve the process, improve the skills, improving deployment scripts and so forth. So you've got various types of things you can apply when you identify where you've got constraints in the process. And within Lean, when they talk about constraints that deal with, and it's very complicated when you read it, but when you understand it a bit more, or when you ask ChatGPT to explain it to you, then you start to understand it. There's three basic approaches. You exploit the constraint. Well, that means you just try and make the best of what you have. You don't make too many changes. You just try and improve what you already have. Subordinate it is basically, okay, the constraint, we can't really do anything with it. We have to adjust everything around it so we're in sync with the constraint, that the rest of the process adjusts to the constraint. So if you've got one point which is slow, then you have to adjust the rest of the process to adjust to that speed, and then elevate the constraint is somehow solve the constraint, which requires some sort of investment in time and energy. So if I've got my incomplete, unreliable business requirement acceptance criteria, what can I do? So exploit it. Well, I can get the testers involved early to help to catch those problems early, help the business analysts think about edge cases, maybe uncover some assumptions. We can give the BA some templates, some examples, checklists. Yeah, I'm currently working on a project where some of the business analysts are doing quite nice and some are not doing so nice. And we said, okay, we'll take the examples from the business analysts. You can do these business requirements very well. Please, rest of business analysts, use these as an example of what you should be doing. This is how it should look. Try and do that. And that can help without doing too much, doing any significant changes. Okay, you've got the business analyst who can't manage, then you just have to wait. You have to decide you're not going to start feature development until the business analyst has done the work they should do and done it in good quality. You have to slow down. Yeah, the developers might have to just wait. If they realize that the business grant are not good enough, they have to stop and say, okay, I'm not going to carry on. It's a waste to carry on. We'll wait till this is fixed. And elevate the constraint. I think the obvious one is fire the business analyst and get a new one. Let's not talk about that, but you can provide training and coaching. You can bring a second BA to help, or ask the product owner to help, or ask the testers to help, or just use a completely different approach to adopt behavior-driven development, for example. Just do it in a completely different way. They're quite big changes. This is why it's elevate the constraint. So teaming, I want to talk about this very briefly. Nearly been talking for nearly an hour, so hopefully another 5 minutes. So if you stick with me, teaming. Now, as I said, we feel the team is key to this. The people in the team, not the team, the people in the team need to be able to work in a way that enables continuous learning, continuous improvement. There is another presentation, I think I'll record it and we'll put it on our Teams channel, all about teaming and collaboration, and it'll explain in quite detail. But I just want to explain maybe 4 key behaviors everybody should be trying to adopt. Yeah, speaking up. If the team's going to learn from something you know or something you see, because all of us see different things. We're humans. We have different filters, different biases. We all see different. We all interpret every situation in a completely different way. It's quite scary, but it's actually quite good because all our different viewpoints, if we add them together, actually enable us to really understand the problem from all sides. And if I don't say anything, if I don't point something out, or if I didn't give my idea, then the team is not going to be able to learn from something I've seen or some idea I have that could help you. So you have to learn to speak up. But also, if somebody else speaks up, then I have to make it safe for that person to talk. Yeah, because we don't feel safe in work often. Yeah, and if somebody, like you feel somebody knows something and got an idea, then encourage them, make it safe for them to speak up. So talking, giving feedback, giving ideas. Collaboration, it's really quite hard to work with people. We've all been in a situation where you've been going, it'd just be more simple for me to do this on my own. Why do I have to do it with this guy? He makes it so complicated. He's got such crazy ideas. I'll just do it on my own. Working with people is really hard, but like the way he looks at it and his ideas and his detailed analysis helps you in a way, or always helps me come up with a better solution. I'm really one of these red people that like to come up with some quick solution and get going. And for me, it's really hard to work with people who are very analytic and need to understand something and need to analyze and process it. And I'm sort of freaking out. Come on, let's go. We've got the idea. Let's go with it. And you say, no, I need to think about this. And I've learned to stop and wait. It's okay. He needs to think about it. He needs to understand it. And once he's understood it, he'll be so on board with the idea, yeah, that we're going to get it. We'll do it, yeah, because he will say, yeah, it's a good idea, and we'll all be committed. And also, he might say, but you didn't think about this, you didn't about that, and I'll be going, oh yeah, of course, yeah, okay, let's change the idea, let's improve the idea, and we work together, and we'll have a much better idea together at the end. It helps to collaborate. You come up with a better idea, in my experience, almost always. Experiment. If you want to do continuous learning and continuous improvement, when you improve something, you have to make a change. And the reason why we have rigid processes is because we are frightened of failure. If we change something, maybe it'll go wrong. Maybe it won't be better than what we did before. We have to be ready to fail. Failing is actually a good thing. It's painful, emotionally painful. As I said, ego doesn't like to admit that we make mistakes, that we're not perfect human beings. We need to present this that we're competent people, yeah, that we're knowledgeable, competent people. We need to present this. This is part of Maslow's pyramid of needs, yeah. So it's very, very hard to fail. You need to adjust your mindset to say, okay, we try it, and if we fail, and if it fails, it's okay because we'll have learned something by trying it. Yeah. Okay. Yeah. There are things. I think it's in Amazon. They have some policy that you can always go back. That the door never closes. Yeah, you can always go back and fix it. Okay, maybe temporarily you have some problem, but you can fix it. But not just fix it, you can actually improve it because you've learned something. You say, okay, that didn't work. Maybe I can do it a different way. And the final thing is the reflection. Again, ego, we don't like to admit we made mistakes. It's important to stop. And like, even if it did go well, to reflect, was it as good as it could have been? I remember doing quite a few big projects and afterwards thinking that was a major success. And I must admit, like 5, 6 years later, I was sitting there saying, really? Did we do it like that? That was really wasn't very good. Yeah, it felt good at the time, but when I think back, I think, well, we could have done that in a better way. That reflection is very important, and be open to the fact that it wasn't as good as you thought it would be. This is really hard though, because as mentioned, it's self-protection. We don't like to fail. It's hard working with other people. We don't always get along. When we get in a situation where people are sharing different ideas and different viewpoints, it often feels like we're getting into a conflict. And for human beings, being in a conflict with other human beings is very, very hard. We are evolutionary bias towards getting along with each other. When you look in the news, it looks like everybody's at war with each other, but actually for a species, we do get on really, really well with each other because we really focus on getting on well with each other. Why? Because if you were living thousands of years ago and you were on your own walking through the jungle and you met a lion or a tiger and you're on your own, well, we don't run very fast, we've got no clothes, we've got no big teeth, we were going to die. But if you were with your tribe, yeah, and we collaborated as a tribe to scare away the animal, then we were going to survive. Our chances of survival were much higher. So being part of the tribe and getting on with everybody is really, really important for us. And when we get in a situation where we're sharing different ideas, it feels a little bit of conflict, and you might get rejected by the tribe, so you don't like to create waves. So that's really, really hard. By nature, we overestimate risk. Going back to my analogy of our ancestor walking in the jungle. Yeah, you've got two of the ancestors walking in the jungle, and there's a noise in the bushes, and one says, "What's that noise?" And the other one says, "I think it might be a lion, we should run." And the other one says, "Nah, it's not a lion." Yeah, which one survived? The one that ran away. That's your ancestor. The other one got killed. His genes didn't go down the gene pool. We overestimate risks. This is basically our evolution. And in work more so. Work's very important. It's our income, it's our self-esteem, whatever. It's much more risky to go through these things in work. I'm getting to the end. My main point is that you can have it all. You have the iron triangle in project management that said, like, you have quality, speed, and cost. And they say it's also a trade-off. If you want more quality, then it can't be fast or cheap, etc. You get the idea. But I believe if you're doing it wrong or you're not doing it well, you can always improve the quality. You can always improve the speed, and you can always make it cheaper. There is no trade-off. If you're just doing the process badly and the people are not qualified or trained or able to do the things in the process, then there's always a way to improve all three things. And as I did these slides and I was working with various slides and had text here and next there, there was kind of like this slide became like a car park. I kept cutting text from one slide and it just ended up here. And at the end, I was thinking, oh, this sounds a little bit like a manifesto. Yeah? We focus on the customer. Quality is defined by the customer. Quality is everybody's job. We prefer prevention over correction. We prefer early detection and correction, shift left. We believe in cooperation, communication, and transparency. We collect data, facts to drive decision-making about quality and what needs to improve. This is a key role of testing. We provide information. Yeah? Our role really isn't finding defects. It really should be providing information about quality. Is the quality there? The quality of the process and people drives the quality of the product. We strive for continuous improvement, not one of fixes of product, process, and people. We are not only testers, we are quality engineers, because we start looking at the quality not just of the product, but of the process and the people. We try and take this complex view of everything. This is what quality engineering is about. It's about building quality in and constantly learning, improving to make the process and the people better and better as we go. Now, if you want to know more, I hope you do, then there's some possibilities for you. The first one is these QR codes hopefully work. I made them myself. We have our Tesena Fest, which is coming up on the 24th and 25th of September. The conference has for the past 3 years had a quality engineering type theme. Even though we don't call it a quality engineering conference, we have 5 great speakers there, and they're talking about subjects related to quality engineering. We have a workshop day the day before where we have a number of topics. I have there a workshop, a practical quality engineering workshop. When I mentioned the quality engineering workshop we do for the client, we'll be doing some of those things there. So if you're curious, you can sign up for that. I think there's maybe 2 or 3 places left. It is pretty sold out. I am a certified trainer for TMAP, Quality for Cross-Functional Teams. This is an excellent basis to learn a lot about quality engineering. And it has a certification. So if your HR department needs you to come away with a certificate that you've been through the course and you understood it, then this is a perfect tool. We are running one of these courses this autumn. You can find that from the QR code. We have our quality engineering workshop, which is a product we offer to clients, either as a one-off workshop or as part of a bigger program. We're working with a couple of clients on a quality engineering program, which is starts with these quality engineering workshops. And I'm hoping soon, well, I have to, because I'm already committed to it, to create a practical introduction to quality engineering. So that's going to be taking a lot of ideas and working on with those ideas in a practical context. And that I would like to do as an in-house course only, and it should be available at the end of the year, because it would be good to take a team for a couple of days and work on quality engineering, talk about quality engineering topics, and get them to work on one of their projects to actually apply some of the ideas. So that's the idea behind that. So that's what the next steps are. I've managed to talk for an hour, which surprises me, but okay. And that's it. Thanks for listening.